we are going to tackle problem 17 in homework 15. This problem is about a function, and we want to know its 4 critical points and whether or not at each critical point there is a local maximum, a local minimum, or a saddle point. And you're given certain information about the function. We have the derivative with respect to x, the derivative with respect to y, the derivative with respect to x twice, the second derivative with respect to y twice, and then the second derivative with respect to x and then y. To get started, we want to set the first derivative with respect to x and the first derivative with respect to y equal to 0. So we're looking at this function equal to 0, and we're looking at this function equal to 0. And we can see that it's a little bit easier to tell when f sub y is equal to 0, because it's just going to be at y equals 0, or when x is plus or minus 1. So we want to look at each of those cases and figure out when f sub x is 0. So when y equals 0, we plug that into f sub x equation up here, and we have minus 18x squared plus 10x has to be 0. We factor out an x, and we have x times a minus 18x plus 10 then has to be 0. That leaves 2 possibilities, x equals 0 or x equals 5/9. That gives us then 2 points. X is 0 and y is 0. X is 5/9 and y is 0. So these are the 2 points that we get when y equals 0. We go back up here, we still need to consider x squared minus 1 being 0, so that gives us 2 possibilities for x. We look first at x equals 1. When x equals 1, we plug that back into the formula for f sub x, because we want that to be 0 as well, and we get 2y squared minus 18 plus 10, so that gives me 2y squared minus 8 equals 0. Factor out a 2, and then we can see y is either 2 or y is minus 2. That gives us 2 more points then. We're going to get the point x equal to 1, y equals to 2, and then x equal to 1 and y equals minus 2. So we have 4 points altogether. Now the last thing we need to try, just to be sure that we're not missing something, is x equals minus 1. And indeed, when you plug in x equals minus 1 into f sub x, we're going to get a minus 2y squared, a minus 18, and a minus 10. So we're going to get x equals, when x equals minus 1, that minus 2y squared minus 28 equals 0. Since this is always less than or equal to minus 28, there's no way it can equal 0, so there's no solutions in this case. Now we've found the 4 critical points, and what we need to do is determine whether they are local maximums there, or local minimums, or saddle points. So for that, we use the second derivative test, and so we need this function d, which is the second derivative with respect to x twice times the second derivative with respect to y twice minus the second derivative with respect to x and then y squared. Recall that all this information that we need then is given with the problem, and so we just go ahead and plug in each of the points we have and see what happens. So when I plug in 0, 0 into f sub xx, I get 10. That's where this 10 is coming from. I get a minus 2 when I plug it into f sub yy. And then when I plug in 0, 0 here, I'm going to get 0 squared. But of course, that's not even important because we already know it's going to be negative just by looking at this expression here. And so we have it's less than 0. And so there's a saddle point at 0, 0. Trying 5/9 next, we plug in 5/9 for x into here, and y is 0, so this goes away. And we need 5/9 times 36 here. We'll get just 4 times 5, which makes us minus 20 plus 10. And so that's giving me minus 10. When I plug in 5/9 here, well, I'm not going to even worry too much about this. I'm just going to write this as 2 times 5/9 squared minus 2. Since y is 0, we still get 0 for that, and so we have 0 squared here that we're subtracting. Notice that 5/9 squared is less than 1. It's 25 over 81, and since it's less than 1, when I multiply it by 2, I have something less than 2 minus 2, and so this will be negative. We have a product of 2 negative numbers, and so that makes this positive, and whenever d is positive, that means we have a local maximum or a local minimum. We look at the derivative with respect to x twice to see which one it is, and that was minus 10. That's where this minus 10 came from. That is negative, which means that the graph in the x direction is going to be concave down, and so we're going to have a local maximum at 590. The next point to plug in is 1, 2, and we can handle 1 minus 2 at the same time, the two remaining points, because I want you to notice that when x equals 1, f sub y is just 0. So when I multiply f sub x times f sub y, I'm just going to get 0 in both of these cases. And then we need to plug in 1, 2 into the f sub xy, and that's going to give me 8. And when I plug in 1 minus 2, I'm going to get minus 8. So in the case of 1, 2, I get 0 minus 8 squared. And in the case of 1 minus 2, I get 0 minus negative 8 squared. In both cases, this is minus 64, and that's less than 0. And so we have a saddle point at 1, 2, and a saddle point at 1 minus 2. So that gives me all the 4 points, the critical points, and what they are at that point for the function. So that finishes this